Autonomous vehicles need to interact with other vehicles in order to do many driving tasks, such as changing lanes as shown here. As a result, most AV autonomy stacks use a prediction model to generate the potential future motion of other drivers, which they then use to plan their own motion. However, models come with uncertainty. Thus, many recent works investigate how to incorporate uncertainty into a robot's autonomy stack. In this work, we take a different perspective and explore the question, can uncertainty provide insights on human driving? We investigate driving scenarios where an adjacent driver is behaving unpredictably. We introduce unpredictability as a feature for a trajectory optimization reward function. Imagine we have a lane change scenario where this ego car is trying to change into the target lane. If one of the adjacent vehicles is behaving erratically or unpredictably, we expect the trajectory generated using the unpredictability aware reward to stay farther from the erratic car compared to a trajectory generated using an agnostic baseline reward. We observe this behavior in a simulated lane change scenario. The unpredictable car is highlighted in orange. The red ego car follows a trajectory using a baseline reward function, while the green ego car follows a trajectory generated using a reward that incorporates the unpredictability feature. We can see that the unpredictability aware trajectory delays changing lanes and maintains a higher distance from the orange car. We follow an inverse reinforcement learning approach to examine whether incorporating the unpredictability feature produces trajectories that better fit a dataset of human lane changes. We extract lane changes from a human trajectory dataset and use maximum entropy inverse reinforcement learning to learn two lane change reward functions, each of which consists of nonlinear reward features weighted by learned parameters theta. The baseline reward function consists of features that penalize distance from the target lane, deviating from average speed of traffic, having high angular speed, and low time to collision with the preceding and following cars in the lane change maneuver. The unpredictability aware reward function consists of all these baseline features in addition to an altered version of the time to collision features weighted by the unpredictability of the adjacent cars, which is defined as the tracked error of a trajectory prediction model. More details can be found in the paper. We compare lane change trajectories generated using the two models with human trajectories on identical test scenarios. We demonstrate that, on average, trajectories generated using the unpredictability aware reward are consistently more similar to human trajectories than the agnostic baseline. We also highlight qualitative observations from scenarios in the test dataset. First, let's look at a scenario with no unpredictable adjacent cars, figure 3 in the paper. On the left, we have the human car's trajectory from the dataset. On the right, we swap out the human trajectory with trajectories generated using the two models for the same scenario. As we expect, in the case of no unpredictable adjacent cars, the two models generate nearly identical trajectories. Now let's look at a scenario with an unpredictable preceding car, figure 4 in the paper. The orange car behaves unpredictably by changing lanes nearly simultaneously as the human ego vehicle. When we swap out the human trajectory with trajectories generated using the two models, we can see that the unpredictability aware trajectory delays changing lanes and maintains a higher distance with the orange car compared to the agnostic baseline. In conclusion, we introduced an unpredictability feature for lane changes based on tracking the performance of a prediction model. We demonstrated that incorporating this feature in a lane change trajectory optimization reward resulted in a better fit to human data than using a baseline reward. However, there are limitations to the scope of our study, which are discussed in detail in the paper. We believe our quantitative and qualitative results serve as an encouraging indication that unpredictability may have a role in driving behavior and motivate further investigation.